Hi everyone, welcome to our webinar, Machine Learning Models Infosec at Scale with Graviton. My name is Ilanit and I'm the VP Marketing for 2B Cloud. Quickly before we start, we just want to mention that at 2B Cloud, we strive for excellency in enriching the entire ecosystem. And we want to make sure that everything we do, including our webinars, are as inclusive for everyone. So please share your questions throughout this webinar and they'll all be answered. This webinar is being recorded. You won't be shown on screen, and it will be available on demand on our YouTube channel. And of course, please submit your questions throughout this entire webinar, and you'll be answered. Two sentences about us. So 2B Cloud, we are an Azure and AWS partner. We focus on working solely with startups and digital native companies. We serve over 400 customers worldwide with a 98% customer satisfaction rate. We offer zero-cost AWS reselling services such as cloud consulting, 24/7 tech support, and cost optimization. If you want to reach out to us and hear more about how we can help you scale your cloud or want to see if you're compatible for Graviton, feel free to scan this QR code, send us a link, and we'll be in touch. And now, without further ado, I want to present our first speaker, Lorenzo.
Good afternoon, everybody. I'm super excited to be here. Thanks so much for that intro. My name is Lorenzo Winfrey. I'm a senior go-to-market specialist for efficient compute at AWS. Efficient compute, for those who might not know what it means, is includes things like Spot, Graviton, auto-scaling groups, fleets, and savings plans. And I'm super excited to be here today with 2B to talk a little bit about machine learning inference models at scale and how Graviton can really have a big impact on that. So I know you all are probably really here for Emmett's demo a little bit later, so I won't waste too much time, but I do want to go over a couple of things about Graviton and how it can have a great effect in this space. Slide, please. So kind of off the bat, just kind of in general, at AWS, we definitely feel like we have the broadest and deepest compute infrastructure for AI ML, and that's CPU, GPU, and custom accelerators in terms of EC2 instances. As you can see, we have a large gambit of instance types that support traditional machine learning as well as deep learning, and that's going to be across multiple processor types, including Intel, AMD, and specifically what we're here to talk to today, which is Graviton, which is our custom silicon, as well as NVIDIA GPUs that are, of course, all the rage. Next slide, please. So when we think about the journey of kind of silicon innovation at AWS, it's just been a great journey. Kind of at the basis of this, we always love to talk about the AWS Nitro system, which is kind of at the foundation of all of our modern EC2 instances. And kind of the simple way to think about it and the power of it is that the Nitro system has multiple components that allow us to offload specific functions, think about networking, think about storage, communications, things like that, to specific and dedicated chips, kind of allowing the CPUs themselves or GPUs to do just the job that they were kind of designed for, helping us to maximize performance as well as improve security. Kind of in the middle of that, of course, is Graviton kind of at the core there, which is very versatile, powerful and efficient, and definitely always want to double tap on that energy efficiency that we talk about and see out of Graviton, which I'll talk about a little bit later. And even though I'm not going to get into detail on it here in today's session, I definitely have to shout out our AWS Inferentia and AWS Trainium instances. Again, these are our own custom silicon designed specifically for inference and training. So while I'm not going to talk about it here today, definitely encourage you all to check out Inference and Trainium if you have those type of workloads. Slide, please. So I love this kind of slide because it kind of really brings things home when we talk about the kind of instances and accelerators that are available here at AWS for ML inference. And again, this chart kind of covers the gambit. I'm of course only going to be chatting about Graviton here today, but we do kind of want to show the versatility and range that we talked about in that first slide in terms of like a deep portfolio, whether we're talking about CPU only, so we're leveraging things like C7G on Graviton or C6i, C6a on Intel and AMD, or whether we're talking GPUs, right? So P4s, G4, G5s, as well as AWS Inference and Trainium. As you can see from the graphic here, the thing that we want to try to drive home here is that every one of these kind of instance types has kind of pros and cons. They have their own strengths and weaknesses, and it is kind of be up to you to determine which one is going to be kind of most well suited for your workloads. But the key here at AWS that we love to talk about is just the broad choice. If you have workloads that latency is going to be important, then of course you see Graviton really excels there. If you're looking in other spaces where you're talking about cost efficiency, if we're talking about broad model support, you see there different instance types are going to have an advantage, but kind of definitely just want to bring home kind of the broad and depth of the portfolio there. So why Graviton? Why AWS Graviton? So off the bat, we always love to talk about up to 40% better price performance for a broad spectrum of workloads as compared to their x86 counterparts. So oftentimes when we're thinking about a specific instance family, CMR, the Graviton instance in that family is going to deliver the best price performance benefit in their respective instance families. Of course, 20% less expensive. And so when you think about that in terms of leveraging Graviton, whether that's for ML inference or kind of any broader general workloads, in a lot of those cases, moving to Graviton, you just can look forward to saving 20% and then potentially also achieve a performance improvement as well. And then, of course, not to be forgotten is this bottom line here, which is Graviton is up to 60% more energy efficient versus comparable EC2 instances. So it definitely not only helps you to save money, potentially improve performance, but also helps to drive forward on your sustainability initiatives. So when we think about the Graviton processor, it's one of the things that keeps me kind of most excited. I love working on it. As you can see there from the top, we are on our 4th generation of Graviton instances. So Graviton is definitely something that we are extremely committed to here at AWS. It is, again, like I said, custom silicon based on the ARM64 architecture. Most people probably got exposed to it a long time ago without knowing it via the chips inside of their mobile phones. And really, when we think about Graviton, we've designed it to be for cloud native workloads, right from the ground up. We had, taken all the feedback we got from all of our great customers and used that to design a processor that was optimized for the type of workloads that we were seeing in the cloud to help customers rapidly innovate and build solutions to help drive their businesses forward. So a question I get asked all the time is, hey, Zoe, this sounds great, but what type of workloads can Graviton apply to? And of course, we're going to talk a little bit more deeper here in a second about Graviton and ML inference. But the answer to that question is that Graviton has broad workload applicability, across a range of areas, including things like HPC, electronic design, automation, media encoding, analytics, microservices. Every day, the amount of workloads and the use cases for Graviton expands, and I'm excited to see where it continues to go. So jumping down a little bit here, specifically into kind of Graviton, I want to key on Graviton 3 for ML inference. We recently launched Graviton 4, which I'll do a little plug about here a little bit later, but kind of locking in on Graviton 3. Graviton 3 has, of course, been out quite a while here, and it's available in pretty much every region. So want to kind of lock in here. And when we think about when to use kind of Graviton 3 for ML inference, we want to think about traditional ML scenarios for classification, for ranking, and for kind of clustering. And so when we start thinking about things like deep learning, right? So we've got single stream real-time inference, natural language process, NLP. Of course, the use cases for that continue to explode. Generative AI use cases, when we're talking about smaller to medium models, so think things like chatbots. And one of my favorite topics recently that I think is going to continue to be at the forefront of Gen AI conversation here over the next couple of years as things evolve is small language models. So we think about, kind of all of the large language models that we've heard of before, but small language models offer a unique opportunity to be able to train kind of these smaller models, kind of focus on a specific area of domain, and be able to do that in a way that is going to be much faster and also much cheaper than those large language models. And so it's really an interesting area in terms of kind of, being able to drive and drive Gen AI production workloads, Gen AI workloads to production faster. So definitely excited to see where that goes. So next question there is kind of when to use AWS Graviton 3 for ML training. So in this area, we really want to think about that data preparation phase. We want to think about kind of traditional ML models, sparse neural networks, and again, kind of fine tuning or transfer learning of those smaller to medium sized networks is really where you're going to see Graviton 3 be able to really shine. Just kind of here on the right side in the graphic here, I won't get kind of too deep down in the weeds on this, but I do want to kind of point out kind of bfloat 16. And so when you start talking about carrying out really complex calculations, being able to have that type of support is always going to be really valuable in this area. Another key thing I want to point out too is because I understand that when you're thinking about how to execute these workloads, you want to be able to use the things that kind of you're used to using and the things that are most popular. And that's where when we think about optimized ML framework, support for Graviton 3, as you can see here, it is quite varied. You've got kind of all the usual suspects, PyTorch, TensorFlow, Anaconda, Llama. So just kind of definitely want to drive home there that the existing kind of support for some of the more popular and most used frameworks are already there, and we're working on growing that support out every day. So I hear you. You're saying, Zoe, that sounds great, but kind of what about performance? I'm so glad you asked. So when we think about kind of performance here, it's kind of this little formula that we see here a little bit, right? So when we Graviton 3, every generation, we're pushing to improve not only energy efficiency, but performance generation over generation. And that was no different when we talked about the move to Graviton 3. We actually saw a leap in performance. So, 2 times performance in terms of vector width, 1.5 times memory bandwidth, and kind of bfloat 16 support. You combine that with a large amount of improvements in those areas that we talked about on that previous slide in terms of support around TensorFlow, PyTorch, and the ARM compute library. You combine those 2 things together and you get the fastest CPU-based machine learning inference with TensorFlow and PyTorch across many models. And so as you can see there, just kind of in the slide on the right here, where you see the 3rd generation or the 2nd generation Graviton instance matched up against the 3rd generation Graviton 3 instances. As you can see there, the performance and the improvements across some of those is very large. So we're looking to continue to push that forward with Graviton 4 here as well. So definitely want to point that out. And speaking of Graviton 4, I'm so excited. Graviton 4 was originally announced at reInvent 2023, and it just recently here, a few weeks ago, went GA. And so when we think about Graviton 4, we launched the GA for the R8G instance types. For folks that might not be aware, the R8G or the R instances are our memory optimized instances. So the naming convention here at AWS, of course, means something. So so C, of course, is going to be for our compute optimized instances. M are our general purpose, and R, of course, is memory optimized. So the R8G is generally available compared to Graviton 3. The Graviton 4 R8G instances provide up to 30% better performance, up to 3 times more vCPUs, which is perfect for these type of workloads when we talk about machine learning inference, and deliver up to 75% more memory bandwidth. So like I said, it's relatively new, so we don't have a lot of kind of stats on that. But if you see the shift from Graviton 2 to Graviton 3, then you can kind of extrapolate what the performance is going to look like going from Graviton 3 to Graviton 4. And I'm super excited to see what all of you do with it. And getting here to the close, because like I said, I know you all are really here to see the great demo that Emmett's going to put on here in a second. But kind of as I conclude, I want to kind of cover just 4 key points here, which is most of the functionality available on x86 based AWS instances. So Intel and AMD are also supported on AWS Graviton instances, allowing Graviton to, of course, run a wide range of the more popular ML workload. So you're not going to have to kind of do anything extra to be able to leverage Graviton to do this. When we think about ML, a lot of times, of course, we think GPUs, but CPUs do offer ease of use in terms of things like data preparation, debuggability, and interpretability, which is oftentimes desired for some ML workloads due to compliance and other requirements. Right? Going back to that broad and deep portfolio of instance types. Finding the right instance for your particular needs at the time and being able to have tons of options is what we want to kind of drive home there. AWS Graviton can be used for doing training and inferencing of some common classical ML and inferencing on deep learning and Gen AI. Again, think small language models. If you haven't heard about small language models yet, definitely check it out. You're going to be hearing much more in the future, at least in my opinion. And finally, when it comes to Graviton, kind of driving back to that original point that I opened with, is that AWS Graviton provides a performance and a price performance advantage and is supported by several of the most popular AI and ML frameworks. So before I finish, I just want to drop these QR codes on screen to point you to some of the resources related to getting started on Graviton. So there's a link to our fast start. There's one to our transition guide and technical guide with tons of information on leveraging Graviton across ML, as well as a broad other range of workloads, and just also providing information around how to further tune and optimize Graviton to kind of get the maximum performance that you're looking for. So definitely check those out if you're interested. And finally, here at AWS, we always encourage continuous learning, and it's something that is close to my heart as well. So I definitely want to encourage you all to check out AWS Skill Builder. It's going to help you to be able to kind of learn at your own place. You're going to be able to increase your knowledge. Definitely recommend checking out some of our ramp up guides on that area. And finally, not for nothing, that you can have the opportunity to earn your compute badge. So definitely check out Skill Builder. I'm a huge fan of it. Go at your own pace and continue to increase your knowledge. All right. That is all for me today. I want to again say thank you so much to 2B for kind of having me on. And I will hand it over to Emmett to show you a demo and show you Graviton and ML Inference in action.
Awesome. Thank you, Lorenzo. So as you heard from Lorenzo, we basically are 2B Cloud, and he highlighted many of the most important things, like how you can actually use a Graviton to save not just on the cost, how you can scale machine learning model. We're going to see a hands-on demo of that using Skill Builder. Lorenzo mentioned use of Skill Builder. We're going to be actually doing a demo using the Skill Builder. But this is a high-level view of what we plan to cover in the demo. At a high level, we'll basically cover how ML model development happens, what are the different steps to do that. And once you have done a model, the most important step here is what are the different inference options. You can basically, once you deploy the model, you can have inference done in real time. You can do batch, asynchronous, serverless, and there are different use cases associated with each one of them. Next, we'll cover the real-time inference hosting options. This is the most important one because of the fact that you can have multiple models in the same container, or you can have multiple containers for each of the model, or you can develop a pipeline for inference as well. Then subsequently, we'll go through an inference architecture and a design decisions, which are the most important for an architect or any data scientist as we go through development as well as deployment of an ML model. And lastly, the important thing is to test. How do you make sure your model is scaling and you're performing to the metrics you have? We'll go through some of the tooling involving Inference Recommender for testing. Next slide, please. So this is a typical step needed to develop and deploy the model. The first step is basically setup. You can use SageMaker, and within the SageMaker, you can actually do the data processing. And within the SageMaker, I'll show you during the demo how you can actually do data wrangling. That's the most important thing. If you basically want to mash up data or do transform data before you could consume it for the model, basically all that is built into that SageMaker. That's the most important thing. You can use EMR cluster to basically pre-process your data and then use it for the model development. You can use your glue pipeline. Those are multiple glue pipelines, and orchestration can be used to basically not just transform the data, but essentially store it in S3 and use it for model development. You can do feature store development as part of the same SageMaker platform. So once we have done that, we have done the model development, and the most important step in here is the model deployment and inference. Now, there are a lot of aspects to model deployment and inference. The most important thing is the model registry, how you do the pipeline and deployment using the pipeline. But the most important thing in here is to understand that what we're going to cover is that what are the different inference options? What are the different options to do the model hosting? And how do we go about doing the endpoint testing? We won't be covering the monitoring, but that's also one of the most important aspects of once you've done the model deployment in production, how do you monitor so it performs the way it's supposed to be performing in production environment? Next slide, please. So here are the different machine learning model inference options. You can do real-time inference, you can do batch transformation, you can do asynchronous inference, or you can do serverless inference. Now, each one is related to a specific use case you can have. So we'll go through each one of them in a little more detail as we do the demo. Next slide, please. Yeah. So when do we use a real-time inference, right? The real-time inference is valid when you basically need to consume inference from the model on a real-time basis. Now, typically, if you have, let's say, for example, you have a credit card and you wanted to detect a fraud, you don't want any latency associated with the detection of a fraud. You want to notify the consumer in real time as the fraud is being detected. That's a real-time inference where you're basically detecting certain information in real time, and the latency requirements are pretty low. And there's a fact that you basically need interactive response. You can alert the users in real time via messaging or in real time if you're using mobile app. Now, when we go to the demo, we'll go through a use case where a sales team wants to do a marketing of a product to a customer using email campaign, and the records that are coming in are in a real time. So we'll do the real time inference using SageMaker, and I'll be showing that demo. But ideally, the use case here is that when you are on a e-commerce site, you want to detect fraud or you want to do personalized recommendation, you want to use a real-time inference option at that point. Next slide, please. So next option here is the serverless inference. Now, not always you're going to need to have your infrastructure as well as that's hosting the model to be available 24/7. You want basically there could be time when it could be your workloads are idle. During those cases where you have a workloads being idle and you have a cold start you need to do, in this particular case, you want to use a serverless inference model. You will be saving on the cost as well. The idea here is that basically you will have you want a model that will allow you to process large amount of data, as large as 1 GB, but at the same time, it can be invoked when it's needed. So what are the use cases associated with serverless inference? So for example, if you want to extract large amount of document data and then you want to consume that data through the model, that would be the one I can think of. And you can consume that data using chatbot. As you can see, most people would go into the chatbot, but there will be idle times. It won't consume it right away. So that would be the use case for the serverless inference. There are inference you can consume asynchronously as well. Now, this is a use case where you have a large payload size. It could be as large as 1 gigabyte, and the processing time associated with that is a pretty large, meaning it could take a long time to process the data, as long as 15 minutes, and you still need a low latency requirement. In this kind of a situation, you would probably want to have a inference which is you can consume using asynchronously. Now, for example, in this case, you have credit risk prediction. Say, for example, you process a large amount of data doing the credit risk prediction, or you have machine learning where you basically a machine produces the data, and you're trying to predict when it would actually break down. In those particular cases, you basically would want to have the machine learning, inference to be asynchronous, because of the fact that you need low latency, but the amount of data being consumed is pretty large, and the payload is large. We'll come to this particular case later on as you see that. But coming back to this, in this demo, you'll probably see a workload that's pretty large, 1 gigabyte of data, and how you process using asynchronous. Now, if you have a data that you basically need to transform a large amount of data set, and then you want to process the data set, store it in S3, and then consume it via another inference endpoint, you would probably do that using batch inference. And in this particular case, the use case, you don't have an interactive request response. You basically have a batch process through which you consume the data. So, for example, in this case, let's say you're trying to predict a churn of different customers, and you have a data. You would probably use batch inference in this particular case. And again, when we come to the actual demo, I'll show you how that actually works. So once you've developed in the real-time inference model, you can consume that model using multiple ways. One is the fact that you can have a multiple model within the same container. And that would basically a use case where you want to reduce the cost, and you want to use you have a container that can be shared across different models. Now, that's one option to pursue. The second option is you could have multiple containers, each with the different frameworks and the way that own latency and non-functional requirements. In those particular cases, you would have multiple containers, one per model, and you would probably have multiple frameworks as well. So that is another deployment model that you could have within the SageMaker. Lastly, you can have an inference pipeline where you have a model which is doing the pre-processing, and you have a model that does post-processing. And then you have a pipeline of models that are basically processing the request coming from the requester. So that is an inference pipeline. You can, in that particular case, you can support 2 to 15 containers, combine all the steps that involves pre-processing, prediction, and post-processing, and you execute the request as if it's a pipeline. Now, going into the most important thing is that as you do the inference using Graviton, what are the design considerations you need to be knowledgeable about? One is the service level agreement. Most companies that are consuming the model, they would want to have an SLA with their customers. And if you, again, as I mentioned earlier, if you need a low latency requirement, you want to consume the model in the real time. But if you basically don't have that, you can probably consume it batch or serverless model. Latency is one of the important criteria to satisfy the SLA requirement. Other one is a throughput. If you have an e-commerce site, which basically needs a high throughput, then in that case, you would want to make a decision whether you want to go with the real time or asynchronous, right? So those are latency also plays and throughput plays an important role in satisfying the SLA requirement of the customer. And if you look at the second most important thing is the cost. How do you, and the cost is most important to the people who are in the finance. You would want to make sure that your cost of consuming the model is within the budget and you're monitoring all the cost parameters that are needed. If you're a data engineer or a data scientist, the most important to you is that what is the platform on which the model is being consumed, and it's a CPU, GPU, how is the infrastructure being managed. Those criteria are important for platform engineers as well. Data engineers will play an important role as far as when it comes to the collection of the data, how the model is built out, and what is the payload size, and what is the data truth. All that is important because of the fact that they play an important role in selecting how the inference model should be structured for consumption. Lastly, you need to have basically how would you do the testing? And like I mentioned, you probably SageMaker has a tool built within the recommender that actually you can do a load testing, and I will come to that in the next slide. The other thing is, how would you consume multiple models if you wanted? If you have, you can build a pipeline of models and consume the model, through the pipeline. So what is Inference Recommender? SageMaker Inference Recommender is a tool that is built within the SageMaker. And the idea here is that you basically have a tool that runs the a load test. In this tool, you can probably run it in two different ways, one using default job. And that when you run a default job, basically it will give an instance recommendation in the sense that what instance is most ideal for that particular model. The other one is the advanced job, where we basically, when you run the tool Inference Recommender, you probably, it gives a recommendation on the endpoint, how you should scale the endpoint, and how you could fine tune the model. So with that, let's go into the actual demo. We'll go through this screen. For those of you who have seen this for the first time, you can see that SageMaker Studio has different applications. This is the user interface. I'll walk you briefly through the different functionality of SageMaker Studio. You have a Jupyter Lab that is a web-based IDE that you can use for building out the notebooks, code, and the data. You have an R Studio that allows you to do analysis of using R. And you can build out, Canvas is another application that allows you to build and use generative AI models. And in this particular case, you can do a complete preparation of the data, training the model, do the prediction, all using the Canvas, and no code is required. There's a code editors that allows you, is a Visual Studio-like interface, and to build the code for the ML model. You have Studio Classic, which is the one I would be using for demonstration purpose as such. The other things are over here. You can see different running instances, which are, as you build out different model, each model can have its own unique workspace, and you can see that in the running instances. I mentioned earlier about different data preparation techniques that you can actually use. So SageMaker has ability to do different mashing of the data, or I would say wrangling of the data. And you have a application called Data Wrangler, which allows you to do that. I showed you earlier about feature store. The most important thing is that once you have the data, you have to use that data to, once you have done preparation of the data, do the features. These features are the ones that are used in order to consumed by the model. So you can, the feature store allows you to build out the features and store it. You can use EMR cluster to process a large amount of data, and then use that data for the actual consumption of the model. You have jobs, which basically I mentioned about inference optimization. That jobs, you have two types of jobs. One is the default, other one is the advanced. Like I mentioned, you can run both of these jobs for either optimization of the endpoint or the instance optimization. Here are the pipelines you can use. Using SageMaker Studio, you can develop pipelines and run execution of those pipelines either in a multi-mode where you basically have a single container and with all the pipe models, or you can have multiple containers, or you can bring your own containers with each with its own model. The models here basically allows you to create, register, deploy in the models. And here's the jumpstart functionality. You can consume all the public models using SageMaker Studio. You can see the publicly available models, either Hugging Face, Meta, model from Stability or Cohere. You can consume all those models using SageMaker Studio. Finally, if you basically want to do deployment of the endpoints, you can do that using SageMaker as well. So this talks through all the features that SageMaker Studio has. What I have chosen in this particular case is Studio Classic, which I'll be showing here. So in the Studio Classic, I have basically cloned a repository, and this repository shows basically the demonstration of the model that we want to show. So the first thing I'm going to show here is how to deploy a model and then do a real-time inference. So as you can see, this is a notebook, and it has a lot of functionality on the left-hand side. You can navigate here. But let's go through the actual first one, which is how to deploy a model and do a real-time inference. As you can see in this notebook here, the first step is to basically install all the dependency. As I'm doing this real-time inference, I have a dependency on Boto3, Pandas, SageMaker, and Data Wrangler. So I executed all these steps in the interest of the time. But you can see the output of all this execution in the real time as I'm executing this. And the next thing I'm doing is exploring a data set here. So in this particular case, I'm exploring the data set associated with the income, age, work class, education of all. And the idea here is that with this data set, I'm doing certain prediction associated with that. So the next step here, in the real time, as I'm processing the data set, I'm also doing some prediction associated with it okay? And here is the next step associated with the real-time inference of the model. You're setting up the model. You can see this S3 client. You're uploading the model, and you're consuming the model from the S3 bucket. And you're setting the date to use the model name. You're retrieving the container image. So you can basically store the container in S3. You can bring your own container and store it in S3 for consuming. In this particular case, I'm using a container, which is basically framework or XGBoost model version 1.5, and I'm using that to predict the income. So the model that is being built out is an income model for a user or set of users. So subsequently, in the real-time inference, I'm creating an endpoint from the provider's data, and then retraining the model. And this is a step where basically it takes a long time. So I've taken the liberty of executing the model ahead of time. So once the endpoint is created, this is how the endpoint looks like. As you can see, you have endpoint config, and every endpoint has a ARN associated with that. And this is what the endpoint you would be consuming. So you have, in this case, I have created the endpoint, and then essentially at that point, I'm waiting for the endpoint creation to happen complete. Once that is done, I have to consume the endpoint, which is the STARS 2.3 here. And I'm invoking the endpoint for the real-time inference with the real-time customer records. Like I mentioned, I have a set of records which are coming in real time. And once I have built the model and deployed the model, I'm invoking this model to consume the records on doing inference on the record in real-time basis. So this is the code associated with that. You have a SageMaker runtime, and you basically, once a request comes in, you invoke the endpoint with the customer record here. And once that is done, you're basically getting a response in the real time as well. And this is the endpoint associated with this. Once you've done the response here, you can parse the response, and you can basically at that point give a feedback to the customer on what the recommendation would be. So this is the use case where you are actually consuming a real-time record, and you're giving the response interactively to the user. The next I would cover is a asynchronous model, where you basically, let me go to the serverless inference model first. So in the serverless inference model, I'll go through some of the initial steps are very similar, where you set up the model and you basically set up the model using a file that's already in the S3 bucket. Once you've done that, you're creating an endpoint from the provider model. And once you've done that, you basically get an endpoint associated with it. The only difference between here is that when you're invoking the endpoint for the serverless inference with the customer records at this point, you would basically, your endpoint can go through a cold start, and you can optimize when the endpoint can be consumed and how it can scale. So this is the code associated with this, where you basically have a Boto3 client that's invoking the endpoint. And then once you've invoked the endpoint, you're getting the response, and you have a start time. You are managing the invoking the endpoint, but you're also managing that how long will it take to basically invoke that response. And lastly, once you've done it, you basically delete the endpoint in this case. The other two models are very similar, where you're basically invoking, deploying the model on asynchronously, and you're consuming the response asynchronously. So what do I mean by asynchronous, right? You basically, the setting up the model and then creating the endpoints is very much similar to the real-time inference. However, when you're basically consuming the model, you are consuming asynchronously and through an endpoint. So that's the difference between the real-time and asynchronous consumption of the model. So as you can see, you have going through the creation of the endpoint. However, the most important thing is invoking the endpoint. As you can see, you're taking the SageMaker, you're invoking the endpoint async, which is the API associated with invoking the endpoint or consuming the model asynchronously. And once you have the response, you basically give that response back to the user. The batch transform here, we basically, the use case here is you have a large amount of data, and you are processing that data in a batch mode. So the steps are very similar to the other steps you have in the real-time inference, where you basically install the dependency, you set up the model, and you consume. You set up the model using model in the S3 bucket. You create the batch transform job. As you can see here, you're basically creating a instance type you mentioned, and you basically have the strategy. You have multi-records, and then you specify the output, where the output is going to be stored in the S3 bucket. Once you have done that, you basically run and you can see the output here. It's a multi-records. It's a very large output here, where you basically processing a large number of records here. And once you've done that, you basically can run an inference on the data that's stored in the S3 bucket. So that hopefully helps you understand how to basically use SageMaker and Graviton to basically run an inference in a real-time, asynchronous, batch, or serverless mode. Helena, we can stop here. And so thank you again all for attending this webinar. My name is Hemant Javeri. I'm the Global Head of Engineering for 2B Cloud. you have any questions, reach out to on the QR code. Happy to answer any questions.
Thank you, Hemant, and thank you, Lorenzo. Hope you everyone enjoyed our webinar, and if you did, we're excited to share that the next episode in this Graviton series, cost-effective web hosting on AWS Graviton, is going to be September 23rd, and registration is already open. So if you want to register now and make sure you don't miss out, please scan this QR code. And once again, if you have any questions, you want to talk to us and see how we can help you implement Graviton on your environment, scan this QR code, and we'll be happy to be in touch with you in the future. Thank you, and hope you